So I'm Stephen Meyers. I'm a professor of geoscience at the University of Wisconsin-Madison, and my expertise is paleoclimatology. The field of paleoclimatology studies past climate changes recorded in, for example, sediments at the bottom of the ocean, sediments at the bottom of lakes, rocks. And by looking at those records, we can infer how the climate system works and maybe ascertain some information about where we're going in the future.
So how did you get involved in Lakes 380 research?
I was on sabbatical in 2017. Now, by the way, I should say that I think this shows how new possibilities and new opportunities in collaboration and pushing science forward emerge from unexpected places. I was on sabbatical working at GNS Science with a group to study Antarctica and to study evolution, in fact, deeper in Earth's history. And Marcus was in an office 2 doors down. And the idea for Lakes 380 came up, and he knew about my areas of expertise in geochemistry and in the statistical analysis of data to understand climate change, and invited me, I think on a whim, said, "Steve, you'd be good for this. Would you like to participate? We're going to give this a shot, this grant." And lo and behold, here I am. So lots of chance occurrences and moments of opportunity that were just recognized, and this was Marcus's vision, I would say. And I have to imagine that a lot of the success of Lakes 380 is from that vision of the leaders and seeing possibilities in all sorts of collaborators that emerged to them.
And who else are you working with in the Lakes 380 team?
Marcus is my main connection through to Lakes 380. The work I'm doing, though, connects in to many other scientists. For example, the DNA records that are being used to reconstruct ecosystem evolution. I studied the geochemistry of the particles, that is, the chemical signals preserved in those particles at the bottom of the lake. Those chemical signals in the mud and the shells come from the water, and the water in the lake is responding to climate change. It's one of the things that it responds to. So that's my area of expertise, and what I'm hoping to lend to this project is the studying of those chemical signals to infer the history of lakes before we have any records of such, of lake behavior.
So is there anything that you think that will be unique from a New Zealand study? For example, given that humans were a lot later arriving here than they have been in other land masses.
So there are two parts to this project there's so many parts of this project that are spectacular, but there are two parts that come to mind in sort of ways it's pushing the science forward in a big way. And some of these ways are absolutely unique to New Zealand, and some of them are more universal. So the unique aspect is the problem that we have when we study ancient climate variability in the rock record, or for example in tree rings, and there's other ways of doing this. It's oftentimes difficult to separate out the natural variability from that is due to humans and their presence. This could be many things. For example, today we're burning fossil fuels and we're changing global climate, but it also could be regional variability. For example, changes in deforestation that influence sediment delivery to a lake and its health. And this has been something that's been very difficult to separate out. So the history of human habitation of New Zealand provides a very unique opportunity, since it's the last place on the planet to be inhabited by humans. And because that history is really well known, we can look before that, and we can look at the sequential inhabitation of New Zealand and see how potentially humans have impacted it. And also then look at the natural variability and how these things are intersecting. So that's something that's unique to New Zealand. The thing that's universal about this, well, I'm sure we'll learn many universal things just from that alone, but it's providing an encyclopedia of lakes. This doesn't exist. So 380 lakes from ocean to mountain peak, from low latitude to higher latitude. This is going to be, in my mind, a game changer in the understanding of lakes and in providing this encyclopedic knowledge of how lakes have varied through the past 1,000 years, but even beyond that, some of these records will be stretched much deeper in time. That's going to be of value to the world, for sure.
So in your work, are you looking at the influences of humans on these systems as well?
So this is where I would say Marcus had some vision in sort of viewing what I do in a different way. So most of my work has not been about humans' engagement with the natural environment. Most of my work has focused on millions of years ago tens of millions of years ago, hundreds of millions of years ago, and trying to understand how the climate system functioned. For example, 100 million years ago, when there was probably 6 times as much carbon dioxide in the atmosphere, and it was what's called a greenhouse world. How did the Earth work when the dinosaurs were roaming the planet? And CO2 is increasing in the atmosphere. We're raising global temperatures. This type of information from the deep past is potentially of great value. What Marcus saw, I think, was an opportunity to apply my expertise in a new way, and to apply these geochemical and statistical methodologies to understand these more recent problems or recent questions about climate system evolution. I've done a little bit of work on what's called the Holocene, but the most recent interval. But most of my work has been in much deeper time.
So how do you feel about engaging in the Anthropocene?
I view all the work that I'm doing in the ancient times, millions of years ago, as relevant to understanding the now. There's so many ways, by the way, that this is in terms of understanding basic mechanisms, but also in understanding that the present moment is dependent upon all the contingencies of the past and everything that has occurred that has led to this moment right now. And so that's another way that studying our deep history informs our present. The Anthropocene is interesting. I have a lot of opinions on this word, for example, but I would say it's really fun and exciting for me to be engaged in this study, which is, as I said, it's almost like an encyclopedia of lakes and understanding how they've varied in human impact on lakes and natural variability. And it's exciting. It's a unique experience. I can't think of anywhere else in the world where one could have such a comprehensive study is being conducted.
So in what ways may science take this sort of information and make it much more understandable to the general public or to students who are coming through the field of science?
I've thought a lot about this. So I'm trained as a research scientist, and I got into this world of paleoclimatology. I went through graduate school and through postdocs and all of that for the love of the research and the love of the learning and the love of exploring new mental theoretical worlds, to maybe seeing something that hadn't been seen before and discovering. One of the highlights of my research career was publishing a paper in a journal called Nature, which is really top-notch. It publishes across science some of the most significant findings. And it felt fantastic to achieve that. And then my work was then used to argue against climate change. And so at that point, I realized, this was about 3 years ago, I realized that it wasn't enough to be producing the science and pushing the limits in that way, that I also needed to be pushing the limits in how we communicate science and how we create and cultivate engaged public in terms of science. So we've created this new initiative. This was with my spouse, Gigi Cohen, who is a photographer and photojournalist and social documentary photographer. And the idea of this project is to inspire scientific literacy and to cultivate emotional connections to science. And we do this in the science classroom. So we re-envision these classrooms of 300, 400 students that are not science majors, that are taking it as a requirement. We view this as an opportunity to really try to cultivate a populace where sound logic and sound reason and also empathy for each other sort of govern decision making. And the idea is to sort of re-envision these as an opportunity. And we also then use it as an experimental laboratory. So it's called Tadada Scientific Laboratory. It's an experimental laboratory where we basically bring in filmmakers, musicians, poets, illustrators, artists of all sorts, and we create all sorts of new experiences. I call them connection events, to engage individuals in science, to basically awaken the inner scientist is one of the ideas. And seeing the science classroom as an opportunity to cultivate empathy through science. In a way, I sort of view science as the art form, is sort of my perspective on it. And so now it's communicating that through other art forms.
To what extent can science be a creative, imaginative field?
My reality is that science feels a certain way to me. It is creative, it is emotional. I'm engaged in this because it connects to my humanity, because it's wondrous. And my opinion is that if every student felt that, they'd want that in their lives, and they'd want to be engaged with science. So how do you do that? How do you create opportunities for them to experience that wonder, that engagement? That's what it's all about. It's basically, I want to give the students the experience that I get to have as a practicing scientist. I want them to have that emotional experience. And I think fundamentally the hypothesis is that that will change them. If they're not already viewing themselves as a scientist, they will at that point. We do have some data on this, so we've done some surveys. We've been doing this for 2 years now, and this last year we did a survey. And we asked the question, has this course, this Geoscience 100, using the Tadada approach, has it changed the way you view the world or yourself, basically as a scientist? And we came in with, I think it was 46% of the students saying that, in fact, they viewed themselves as a scientist, and 92% went out saying they view themselves as a scientist, essentially. So double. Now, we don't have a control group. So this is a new idea that we're doing, and we started to do, the idea was to do some initial surveying. But it seems to be working. And there's so many ways. It's not just about engaging artists and musicians. That's an important part. But it's also just thinking about the way that room is a collaborative. And basically, as I mentioned earlier, viewing collaboration as opening yourself and surrendering yourself to possibilities, and viewing every single student as a collaborator. So now it's 300 collaborators of students, or 400. It's artists and filmmakers that are teachers and collaborators coming in. They're teaching science. In the process, I'm learning about filmmaking, and I'm learning how to be a better scientific communicator, working with comic book artists. So how do you think about science in terms of comic books? It's all about climate change. It's a response to basically that Nature article and the way it was misrepresented. It's the way I can do something to cultivate an informed understanding in the face of times like today, like exists in the world, which have always existed, where ideas are misconstrued sometimes for ill purposes.
So do you think scientists should get more political?
Well, I think that, for me, it's a broader question, and it comes down to this, that there's a tremendous opportunity for scientists to engage with humanity, to engage with their own humanity, and to engage with the humanity that surrounds them. And some aspects of that are political, for sure. I think that what needs to happen, or what ideally would happen in my mind, is within each person, there's an awakening, right? And so how can you make that happen? Some of that is through political engagement. Some of that's through artistic engagement. Some of that's through just having a conversation with whoever you come across. Thank you.
That's great. Thank you.
Thank you.